Hey, it's Loop Dark Snout here, and something to do with premature jubilation? Yeah, that's a little cheesy, isn't it? It's also a little foreboding. What do you mean premature? What? Hey, this sucks. Okay. This is the victory episode. Haha, check me out. Rollout's done. Everything works. See for yourself. All right.
A little after 6 a.m. Monday morning. Oh, well, I thought it would have been done during the night. Nope, but whatever. What is it, 87:30? So 160 to go. Times 10 seconds, 12 seconds. Yeah, half an hour. Cool. Well, last frame, of course. Come on. There we go. Okay, what's next? Well, let's just dive in and do it. Okay, this is still off. What do I need to do to play this? Let's start over. Now it is this one, number 5. Now I believe this should get right to it and play the thing. 1.05. Oh, man. Not only did I practically just wake up, oh, well, I guess that's about it. I'm not going to be thinking very clearly. Come on. Now, everything else is already in place. Like, it should be watching for the end. It shouldn't go on into oblivion and execute code that doesn't exist. Although I really haven't tested that yet. I'm going to run one and away we go. Well, yep, okay. It's not going to abandon the color thing. Here we go. We ready? I'm scared. Oh. Haha. This is really it. I don't know what to say. Should I be saying stuff? Well, I mean, you're watching this. Commentary. Well, what I can tell you is I have the interrupt structured where it's counting down from 2 and then introducing a frame, then 3, then 2, then 3, then 2. And the main loop is checking to see if the buffer number, because the buffer numbers go from 0 to 9. Like every time, a new frame is changed, it'll introduce that frame and then increment the buffer number and loop from 10. If it increments to 10, it jumps it to 0. But anyway, it looks to see if the buffer number, if it's 0 to 4, it just waits. And once it hits 5, it fills the 0 to 4 section. And then once the 5 to 9 is out of the way, and it's back down to frame 0, then it fills the 5 to 9s. So it's not as smart as the wolves in the BackBit. It's not sort of following each frame and cleaning up directly behind it, because it's more of a waiting until the chunk of buffers is available. And there's no place or no mechanism in place to watch for frames falling behind. So in fact, if it does fall behind, you're just going to get a visual cue. It'll just be messed up, but the program won't realize it. Same thing with the audio. When the audio does come, it's going to have like a first half of the buffer, second half of the buffer, and then once one half is done, it'll give the cue to go fill it. And as long as the data is brought in and filled before the next need comes along, it won't know that it's really running a fine line between completely screwing up. Now let's take a look at this thing. Not a crazy bunch of flickering, isn't it? That is, well, nice. It's bringing in 5 frames rollout code style at a time. And 5 frames is brought in, well, 2 plus 3, 2 plus 3, well, 10, 12. Yeah, every 12 cycles. I think so. 2, 3, 2, 3, 2. But on the second one, it's every 13. And if we're at 24 frames, yeah, it's about a quarter of a second every blink. That should be 4 per second. Yeah, that's about right. Man, it finally works. So I am only one big step away, which is getting that audio in place. And to do that, well, the process is basically going into my video editor, like on the PC, because, you know, that's where these bitmaps came from. Stripping out the audio for this clip, going into Audacity, turning it into a 8 or 11 or 16 kilobyte mono version. And from that, well, I guess Audacity can do it. I forget what the process is called, but it basically levels out and structures the waveform like you want it. I forget what the word is called, but I ended up going back on my Wolves on the BackBit a second time, like after about a year, and redoing the audio, making it louder. And I'm going to do that obviously for this as well. And what happens after that? Sorry, it is early day. Well, I'm going to create one file on the PC, put it into the SDTIC, bring it in, Mahoney convert it, write it to the BBT using my Rollout code creator. I could probably do 1.05. That'll be fun. A variation of it because it's designed to do the video, but in this case, I'll want it to write the audio. Neat. I got a feeling it's still going to play without any problems with the audio. One thing I have in place here, and I did not include it in my main loop, is I have this subroutine that counts wasted time, like spare time. So anytime it has no time or has time to wait, do the subroutine, increment things, and then when the video is done, assuming no frames were skipped, I can do some calculations and see how much free time the machine actually was spinning in circles. Yeah, it's just kind of neat. 1 megahertz. It's just, I don't know. It's almost over. Now, TI string is not going to give me anything useful here because the interrupts shouldn't be working. But we'll see what happens. Does it crash? Does it come back to basic? Is it back in basic? I don't know. I wonder. Well, it gets that far. And I think it was blanking the screen. And what happens next? Well, it doesn't matter because it chokes. I can fix that. But anyways, cool. Okay, I tried another playback. I got it so it comes back to basic properly now, at least. Sorry. This is my time ticker, waste time counter. So a little over 3 million loops JSR into my time count, which each one is 21 cycles in total. This is the total spare time in cycles during the whole playback. This many seconds, this many frames, this much cycles per frame, divided by how many interrupts at 8 kilohertz audio, 25 cycles per audio interrupt. That's not enough. That's not enough to do audio at 8K. And that's not even including bringing in the audio. So what I have in at the moment, like I said previously, let's see, 3, 4, It when it's playing these buffers, it waits until it's over here, and then it goes to fill it. And then once these have all played and it's playing these ones now, then it fills this chunk of buffers. That's not gonna fly. I'm gonna have to basically expand this, kind of like on Wolves in the BackBit. And as it's playing one, if you're able, fill 0. As it's playing 2, fill 1, and follow, because otherwise it waits until you're at frame 5 and then begins to queue up the data and then run it. 225 pages of rolled out code, which is still pretty fast, but it's waiting. And I don't think I can afford to wait. Oy. Because this delay is not running during the, well, I guess I can. I should include that. While it's waiting for the BackBit queue-ups, it is not running this wasted time counter. I should include that, and we'll see if I get a better result, and maybe I can, make better use of my wait time, because I was kind of getting cocky here thinking I had time to burn, and I don't think I do.
So that played pretty good. So what's the problem here? Well, in the next episode, we're going to find out, because I come across the most confounding thing, and it threatens this entire project. So, well, until then, I'm Luke Darksnow.